All right, we are going to do number 6 as the partial fraction decomposition for the improper rational expression. They gave us a hint right here. Improper. It is improper because the degrees are the same. So anytime the degree on top is greater, or if the degrees are the same, it's actually an improper fraction, and we need to start with long division. So that's what we're going to do first. X squared plus x plus 6. And we're going to divide into x squared minus 4x plus 0. Our goal is to get an x squared, so we need a 1 on top. So that gives us x squared plus x plus 6. Draw the line, change the signs. So here's our remainder. And over what we started with. All right, so now we can just kind of ignore that 1, and we want to decompose x squared plus x plus 6. So we start by factoring that denominator. And that actually can't be factored. There's nothing that multiplies to 6 and adds up to -1. So since this can't be factored anymore, it can't be broken down. So this is actually your answer. Okay, that is as far as it can go. So if you run into a problem that the denominator can't be factored, you're actually done. All right, we have another improper rational expression right here. So again, they gave us a hint right in the problem is that we're going to have to start this with long division. Okay, anytime it's improper, we're going to do long division. So start dividing that. So it looks like we need an x on top. It's going to give us x cubed plus 3x squared minus 4x. Draw the line and change the signs. Did I actually change the sign of that one? Nobody knows. I did, yeah. All right, drop that 1. Looks like we need a -1 on top. So then we get negative x squared minus 3x plus 4. Draw the line and change the signs. All right, so this has divided into x minus 1, and then our remainder is 6x minus 3 over x squared plus 3x minus 4. Okay, I'm just going to erase this long division because I don't have room to do the rest of the problem if I don't. Okay, so now this problem, we have this x minus 1 plus 6x minus 3, and I'm going to factor this. Let's see, that factors into x plus 4, x minus 1. I think that sounds right. Okay, and we want to break that apart. Now, at this point, I'm just going to ignore this x minus 1 thing. We'll come back to it. We want to split this into x plus 4, x minus 1. Those are both linear terms, so just need an a and a b. And that's the problem we want to work with there. So let's multiply to get rid of the fraction. We're going to multiply by x plus 4, x minus 1. All right, and that leaves us with 6x minus 3 equals a, x minus 1 plus b, x plus 4. And that's the equation that we're going to work with and plug into. These are kind of the simpler ones where we just get to pick things for x. So the first thing I'm going to choose is I'm going to let x equal 1. I am going to do some of this in my head, but I'm plugging in 1 into all of these spots. So that gives me 3 equals a times 0 plus 5b. So it looks like b is 3/5. And then I'm going to pick something else easy, probably negative 4. Again, I'm plugging that into all of these spots for x. I'm going to do some of that in my head. So gosh, negative 27. It's not a very nice number. When I plug in negative 4 there, I get negative 5a. And then I just get b times 0, which I don't need. So a is 27/5. All right, so let me show you how to write this answer. This one's a little bit different. So remember, coming up here, we still have that x minus 1. And then we split this into a, which we said was 27/5 over x plus 4. And then we had b, which we said was 3/5. And this is an okay way to write this, but the more common way to write it is to take this 27/5 and put the 27 in the numerator and then drop the 5 down into the denominator. So that's how I want you to write that answer. And do the same thing with 3/5. Leaves the 3 in the numerator, drop the 5 down into the denominator. And this is your partial fraction decomposition.